Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. Today we are going to look at the differences in automotive fuses. About 2 weeks ago, I shot a video on the Hioki milli-ohm meter. It's the model RM3548 resistance meter that can measure very, very small resistance values, clear down to 100 nano-ohms. And I told you in that video that I was going to find some less than reputable fuses to check and compare those to the factory fuses that are put in brand new vehicles here. There are some huge differences in automotive fuses that are available out there. And if you buy a major brand fuse, chances are that you are getting a good high quality fuse. And if you just buy something off of eBay or Amazon or any other online retailer, that you get a huge assortment of fuses for next to nothing cost-wise, chances are you are buying a very bad quality fuse that may not protect the circuit that it is intended to protect. And I'm going to prove that to you. So I've done some experiments. I went online, I looked on Amazon, and I looked on eBay, and I found all kinds of offerings of some generic brand fuse that's available. So I just ordered a box of 120 fuses from eBay. And this one is labeled AJ Wholesale Distributors. But this same box, this same plastic box, I've seen on eBay and Amazon with just a different card underneath each one with a different brand. And I believe they're the same garbage fuses that are out there. And I'm here to tell you that it's a mistake to buy these. It's a mistake to put them in your car. And I'm going to show you why. So I knew that I could buy them online, and I did. But then I thought, I wonder if auto parts stores are selling them around here. And then I thought of Harbor Freight, of course, because they had a recall on this type of fuse back in 2009. And you can see here on their website, they have a recall saying they're calling all of these back and to not use them. General Motors, before that recall, issued a service alert bulletin to their service technicians warning them, don't use these fuses from Harbor Freight or any place else. Only use original equipment fuses that are recommended by the manufacturer. And if you have a vehicle with a wire harness that the harness is getting really hot or is even melted, it could be that the fuse that's in the fuse block might be one of these garbage fuses, and it's not opening, it's not melting at the proper moment in time to protect the wire harness from getting too hot and melting through the insulation and causing short circuits and even possible fires. And so this was dated September of 2007. And I'd forgotten all about that. I'd forgotten about the Harbor Freight fuse recall and all of that until I started messing around with this milli-ohm meter here, this resistance meter from Hioki. And I wondered, can you still get these things? So I'm here to tell you, yes, these are the same lousy fuses that I believe were available back then. They're just available someplace else. So I drove around town and I thought, well, let me check at Harbor Freight to see if they're selling any type of fuses. Maybe they have a different brand. Maybe they have a different type of fuse. So I go to my local Harbor Freight store, which I usually avoid at all costs, and went in and looked around. Not a single fuse in the entire store. They don't sell fuses. Not only that, they didn't have a single multimeter for sale either. Nothing. And I was quite surprised because I'm not impressed with their multimeters either. Okay, so then I thought, well, okay, let's go to the regular auto parts stores around here. So I went to Advanced Auto Parts. I went to O'Reilly Auto Parts. I went to AutoZone. I went to Walmart. My wife went to the dollar store and looked for me. The dollar store is still peddling that lousy oil that they sell, but they didn't have any fuses. Nobody had these garbage fuses out of China that you can still buy online. You go online and you can get this whole box of fuses, 120 fuses, was less than $8 with shipping. 120 fuses for $8, and you would think, oh, hey, all fuses are the same. This is $8. The others are $20 for 40 fuses. I'm going to buy this one. Well, they're not the same. So when I went to Advance Auto Parts, they sell Littelfuse is the brand name, and that Littelfuse is an original equipment manufacturer, supplier of fuses. And I bought this assortment of fuses. There are 40 fuses here, along with a fuse tester that I didn't need, but I wanted an assortment of fuses. This whole kit here with sales tax was $21.29. So almost 3 times the cost of the garbage fuses. And so Littelfuse is a major brand used by automobile manufacturers. This is in a sealed package. I have not opened it yet. We're going to open it and compare these Littelfuses to the other brand fuse that's there. Then I went to AutoZone and O'Reilly's and Walmart, and all of them either were selling Littelfuse or Buss Fuse. Buss, B-U-S-S, is now owned by Eaton Corporation, and I bought a box of 42 fuses. They also make quality fuses and supply fuses to original equipment vehicle manufacturers. And this was roughly the same cost as the package of Littelfuses. With tax, it was $19.22, so $2 less expensive. And this is in a sealed package. I haven't opened it yet, and we will compare all 3 of these fuses. Now, I believe we have 2 good high-quality sets of fuses here from Bussman, and from Littelfuse, which is owned by Cooper. And then we have the garbage fuses. Then I also have, and we've had these here at the shop since 2007, we kept some of those old fuses that were melting wire harnesses, and I have some of those here also, and we'll throw some of those in as a comparison as well. Now, if you go to the website for Littelfuse, they publish for the exact fuse that we bought. These are ATM mini fuses. They publish a specification sheet here, and the specification sheet gives us the cold resistance in milli-ohms, which this milli-ohm meter will measure. It gives us the cold resistance that each fuse should have at room temperature approximately, which is 24 degrees Celsius plus or minus 5 degrees. So that's anywhere from 68 to 84 degrees Fahrenheit is the temperature that we're talking about here. So we have the milli-ohm resistance specification for Littelfuse. They also have a sheet that you can download called Fuseology. It gives you all kinds of good information about fuses if you want to learn more about fuses. If you go to the Bussman website, they also have a data sheet for this box of fuses, or this type of fuse, with all kinds of good information on it, at what current will it blow. It has curve charts of current versus time in seconds, and it also gives us a table of milli-ohm resistance at room temperature. And this table of Bussman is very close to the same as the table for Littelfuse. Now, there's no data sheet at all on these box of fuse that we have here. On both data sheets for the Bussman and the Littelfuses, they refer to the Society of Automotive Engineers standard number J2077. And this standard is titled Miniature Blade Type Electrical Fuses. And it's about 12 pages of technical information on this type of fuse. The size, how to test it, under what conditions do you test it, what temperature do you test it at, how do you run it through all of the cycles of vibration and humidity and dust and moisture, and at what percentage of the current marked on the fuse of overcurrent should the fuse melt at. Because these fuses, they blow. When somebody says a fuse blows or pops, it physically melts. The little element physically melts. And so there are all kinds of specifications here on this particular type of fuse. And I'll give you a little bit of information out of this, but I can't show you the whole thing because it's a copyrighted document that you have to purchase if you want to see the whole thing. All right. Well, let's do some comparisons here. So I'm going to open all three of these boxes next, and we're going to compare the milli-ohm resistance value of a fuse of the same size from each of these brands of fuses. Okay, we are ready to compare 4 different brands of fuses. I have the brand I got from eBay, made in China. I've got the Bus Fuses, the Littelfuse, and then our old Harbor Freight fuses from 2007. Now, the specification for testing these fuses is supposed to be the temperature at 24 degrees Celsius plus or minus 5 degrees. You can see we are at 28.5 degrees here on our temperature sensor on our resistance meter, so we are well within the temperature range for testing these. Okay, we're going to compare 4 different brands of fuses here. I've got the cheap garbage from China right here is one, the Bus Fuses, the Littelfuses, and then our 2007 selection of Harbor Freight fuses that have been recalled. Harbor Freight acknowledged there was a problem and recalled them all. So let's start with a 5 amp fuse. 5 amp fuse is, by specification from the Society of Automotive Engineers, for cars sold in the United States, which, by the way, there's a different European standard from the International Electrotechnical Committee, the IEC, for European vehicles sold outside the United States. All right, so there's a color standard. It tells you for each fuse size what color the housing should be. And so here is a 5 amp fuse from my eBay fuse collection here. The 5 amp fuse is supposed to have 17.75 milliohms of resistance. We have 2.02. Here comes the Bus brand fuse 5 amp, 16.49. Here comes the Littelfuse, 17.63, and our really old Harbor Freight fuse 1.3. 1.31. All right, so that's the 5 amp. Let's do the same thing for the 10. The 10 is supposed to be 7.42 approximately milliohms of resistance. My eBay one is 2.03. The Bus Fuse, Bussman Fuse, 7.49. The Littelfuse, 7.24. And the old Harbor Freight fuses, 1.31. Exact same resistance as the 5 amp fuse that we previously tested. All right, now the 15 amp fuse from my eBay purchase. 15 amp fuse is supposed to be 4.58. We have 3.14. The Bussman, 4.85. The Littelfuse, 4.76. And the old Harbor Freight fuses, 1.31. Exactly the same resistance as the 5 and the 10. Okay, let's do the 20 amp from the eBay purchase. 20 amp is supposed to be 3.21 milliohms. I'm getting 1.18. The Bus Fuse, 3.43. The Littelfuse, 3.54, and the old Harbor Freight fuses 1.0, 1 milliohm. And it should be 3.2. So at least that's a little bit different than the first three fuses of the old Harbor Freights. All right, now the 25s. We're just about done here. We've got to do the 25s and the 30s. So here's the 25 for my eBay purchase, 1.03. By the way, the 25s are supposed to be 2.36. So here is the Bussman Fuse, 2.49. Here is the Littelfuse, 2.59. And then the old Harbor Freight fuses, 0.95. And then the last one, the 30 amp fuse in my eBay purchase, 1.05. Here's the Bussman, 2.04. Oh, these are supposed to be for a 30 amp fuse right around 1.85. The Littelfuse, 2.02. And the old Harbor Freight fuse, 0.97. As you can see here from the resistance table, the lower the amperage rating, the higher the milli-ohm resistance should be. And if we look at the measurements we took here from the bus fuses, they match up very close to the specification. The Littelfuse milli-ohm resistances match up very close, but the fuse kit I bought, they are all, it looks to me like there's only 3 different fuses in a kit where we tested 6 different fuses, because 3 of them have almost identical resistances at around 1 milliohm. 2 of them are almost at 2 milliohms apiece, and then there's one oddball at 3.14. None of those matched the resistances of the spec sheet of the Littelfuse or the bus fuses. They're all too low. And if you compared, let's say the 10 amp fuse is supposed to be 7.42 milliohms of resistance, and it has 2.03. Well, 2.03 lines up with around somewhere between 25 and 30 amps of current, according to the spec sheet here from Littelfuse. So a 10 amp fuse is going to not protect your 10 amp circuit. It's more like a 27 amp fuse based on its resistance. Now the old Harbor Freight ones are even worse than the ones that I've tested here out of this kit from eBay, because it looks like there are only 2 different fuses in all of those 6 that we tested. 3 of them were exactly at 1.31 milliohms each, the 5, 10, and 15 amp, and then the 20, 25, and 30 were all almost exactly at 1.0 milliohms each. So that is so low of resistance that if you look at our resistance specification here, a 30 amp fuse should have 1.85 milliohms of resistance. The highest resistance we had was 1.31 on these old Harbor Freight fuses. So even though they're the right color, they are not the right resistance value. And it's the resistance as the current goes through it that creates a voltage drop, that creates heat, that eventually melts the little element down inside of the fuse itself. A couple of my coworkers that I've talked to said, well, that's all fine, this milliohm resistance stuff, but you really ought to hook it up to a circuit and see when does it really blow. Well, in researching what it takes to blow a fuse, there's quite a lot to that, and I don't have all the equipment to do that for the higher amperage fuses, but I was able to come up with an experiment to show you the temperature increase based on the milliohm resistance and the voltage drop across those fuses. So let's get that set up next. Okay, we're ready to do a test comparing the fuses I bought from eBay versus the good quality fuse. I'm going to use the Littelfuse brand one for this experiment. And so what I have is a fuse holder right here. It's just a wire harness that will hold a fuse. And I'm going to take the 10 amp fuse from the kit that I purchased on eBay and plug it into that fuse holder. I'm going to connect a voltmeter to each of the voltmeter lead to each of the legs so we can measure the voltage drop across the fuse. And if you read the SAE document on testing the fuse, that is where the voltage drop is supposed to be done. So this voltmeter over here on the right is the voltage drop across the fuse. This meter right here will be the current going through this fuse as measured with a current clamp that I have right here. And then this center meter is the temperature of this fuse. And so I have a temperature sensor right here, and I'm just going to tape it to the fuse body. You can see from my body touching the fuse or the temperature sensor element there, it heated up. We'll let that cool down here just a moment while I'm discussing the rest of this. I have another temperature sensor that this meter is monitoring that I have taped to the wire that the current goes through that feeds that fuse. So the fuse holder, one of the two wires on the negative side, that's the temperature of the wire, and then this meter here on the far left is the room temperature. So initially here we're all, other than when I touched it with my body, we were all real close to our room temperature of 84.8, 85 degrees Fahrenheit. Okay, then over here behind me I have an old Sun VAT40, and I'm using that just as a variable load to control current going through the fuse, and I have that connected to a battery down below over here. Okay, so we're real close on our temperatures. So once again, room temperature, the wire temperature by the fuse temperature, the current going through the fuse, and the fuse voltage drop. The last part of the equation will be my phone. I'm going to run this experiment for 5 minutes, and I'll speed it up so you don't have to endure all 5 minutes. But let's take a look at several things. One, let's see how hot the fuse itself gets, because remember, it's the fuse that has to get hot and melt. That metal in there has to physically melt open in order for the fuse to go open. So let's see how hot it gets on a 10 amp fuse just running 10 amps of current through it. And then let's look at the wire temperature at 10 amps and the voltage drop across it at 10 amps. Now, by the way, there's a specification that for a 10 amp fuse, you're never supposed to run 10 amps through it. The maximum allowed is about 75% of that, so 7.5 amps would be the maximum current in a circuit protected by a 10 amp fuse. So if you have a fuse that is blowing intermittently on a customer vehicle, look for aftermarket equipment that's been added on. Maybe they're pulling more current through the fuse than that circuit was intended to handle. Okay, so let's turn the load on now. We're going to watch this current right here, and once it hits 10 amps, then I'm going to start the 5-minute timer. So let's start cranking that up here. Here we go, 5 amps, 6, 9, there's 10.5 amps. I'm going to start the timer right now. 5-minute countdown. So let's watch and see. If our current gets too high, I'll adjust it a little bit. Notice we have a 23 millivolt drop across the fuse at 10.9 amps. Our fuse temperature is increasing. We're at 91 degrees. 88 degrees on the wire temperature, where 84 degrees is the room temperature. Now remember, this is the less than reputable, no-name brand that I bought off of eBay. Okay, our 5 minutes are up. We are at 107 degrees on the fuse, 103 on the wire, still at 84 on the room temperature, 24 millivolt drop, almost 25 across the fuse at 10.8 amps of current. Now let me turn the current off. The amperage test in the SAE document tells us that the fuse shall carry 110% of its rating for a minimum of 100 hours. It also tells us that the fuse shall open in not less than 3/4 of a second and not more than 1800 seconds or 30 minutes at 135% of the rated current. And then it gives us a whole bunch of other specifications there also. So it gives us the quickest time it should go open, and it gives us the longest time that it should go open at this 135% rating. So this was the 10 amp fuse from the box of fuses I bought off of eBay that are totally out of specification for their milli-ohm resistance. So now let's take that fuse out and put in a Littelfuse brand fuse. Now we have to wait for these to cool down just a little bit from the current going through them from our previous test. While that's cooling down, the fuse that we're testing now has a higher resistance, a higher milli-ohm resistance, which is going to have a higher voltage drop across it. Our previous fuse only had a 24.6 millivolt drop across it. I'm going to expect to see a higher one here because it has a higher resistance. If we look at the measurements from our milli-ohm resistances, the fuse that we just tested had a 2 milli-ohm resistance. The fuse we're testing now has a 7.2 milli-ohm resistance. So that should be 3.5 times more. So 3.5 times 24, that's around 80 millivolt drop we should see approximately. We're cooled down to around 87 degrees. That's close enough because these will get hotter. The fuse needs to have a higher voltage drop to have a higher heat buildup, so we're going to expect to see this temperature to increase higher than the 107 that the eBay fuses got up to. The wire temperature was at 103 with 10, 11 amps. That shouldn't change any because current is current. The wire itself won't have any more current going through it. The only thing different here is the fuse resistance was higher, which will cause it to heat up more, and eventually it would heat up enough to melt and open. So let's try that now. So here comes the current. Let's take it up to our 10 amps. All right, here's our 10 amps of current. We'll start the timer. Notice already we are at a 102 millivolt drop versus the 24 that we had before, so almost a little more than 4 times. Our fuse temperature is climbing rapidly. It's at 95. Wire temperature slowly increasing. Room temperature still the same. Let's watch and see what happens. We're going to expect this number to get higher than the 107 of the previous fuse, and this number already is higher. All right, we are a little more than 1 minute in, and we are already at the same temperature that the previous fuse took several minutes to get to. We're still climbing. Okay, our 5 minutes are up on the little fuse, and I have to hold the temperature sensor on to the fuse because my tape has lost its adhesion with the heat. But we're at 120, 126 degrees is what I was seeing there, 120. Our voltage drop across the fuse, I keep losing my clip here, about 120 millivolts over here. 10.7 amps of current, 122 degrees of the fuse, 108 degrees of wire temperature, 84 degrees room temperature. So I need to come up with a better way to hold that temperature sensor on there because that fuse gets too hot for the tape to adhere. So hopefully you can see from this demonstration that if the fuse internal resistance is too low, the fuse doesn't get hot. It doesn't get as hot as it should. And we're not running enough current through it to pop the fuse. But you can see there was a temperature difference there, a 15-degree temperature difference just from the one fuse to the other. We were at 107 on the eBay fuse and 122 to 126 on the Littelfuse brand. So I highly recommend that if you have some of these off-brand fuses that you realize that they may not be up to specification and you may be putting your vehicle, wire harness, and even your lives in danger. If there's a short circuit somewhere while you are driving that disables some other type of system that affects your ability to safely control the vehicle, that could affect your life and the lives of those around you. The more expensive fuses have gone through rigorous testing as specified by the SAE documentation there. They meet certain specifications. The fuse housing material is not supposed to melt until a certain high temperature. At all times when that fuse blows, you should still be able to remove the fuse from the fuse block without it damaging the fuses around it or the fuse block. These fuses, the higher quality fuses, the terminals themselves are tin plated or silver plated or even gold plated in some instances, which gives it better performance at high temperatures. Obviously, the hotter the fuse, the easier it will be for that fuse to melt. If you're driving a vehicle in hot temperatures, if there's hot under hood temperatures or hot temperatures around any fuse block, that will affect the fuse's rating, how much current it can handle without melting. So it's important to keep the fuse box covers on those fuses to help protect them from excessive heat. So I've learned a lot more about fuses than I ever thought I would, and there's a whole bunch more to learn. We're just scratching the surface here. Hopefully the thing you've learned coming out of this video is that all fuses are not the same. Even though they're the same color, they might look the same, you pretty much pay for what you get. I'm not saying that all aftermarket fuses that you buy off of Amazon or eBay are garbage, but a lot of them are. Amazon and eBay sell good quality fuses too. The name brand, the Bussman Fuses, the Littelfuses, and I'm sure there's other brands that are good too. But the point is you just don't know. What you do know is that the major brand ones that you can actually download a data sheet for and with performance curves and performance specifications are most likely to be good quality fuses that should protect the circuits in your vehicle the way they should. If you can't find a data sheet or even a manufacturer on the name of the fuses, only the distributor, then chances are those fuses are no good and you should never use them. Throw them away. Don't buy them. Tell your friends, don't buy them. I'm going to hang on to these just for a good example of a bad set of fuses, but I would never put these in a vehicle. Thank you for watching.